It affects over 26 million Americans, including more than 6 million children.
In medicine, we can't always fix everything, but with asthma, it's reversible. We can't prevent it, we can't cure it right now, but we can really control it if we get it right.
On today's show, we'll focus on asthma and efforts to improve treatments for it. We'll also learn about an asthma-related study focusing on air quality in daycares.
Indoor air quality is believed to be 5 times worse than outdoors, and young children can spend up to 10 hours per day in daycares, so it can have a big impact on kids' health.
And we'll discover an experimental asthma drug that could eliminate the need for inhalers.
I think it would be a relief for the parent anxious about that child getting an asthma attack where they are not present. With an oral application, we could have the parents be less anxious.
It's all about asthma inside this edition of CTSI Discovery Radio. Welcome to CTSI Discovery Radio. I'm your host, Brian Belmer. CTSI Discovery Radio is brought to you by the Clinical and Translational Science Institute of Southeast Wisconsin. The CTSI is a consortium of researchers, doctors, scientists, and others representing 8 institutions, including the Medical College of Wisconsin, Milwaukee School of Engineering, Marquette University, the University of Wisconsin-Milwaukee, Children's Hospital of Wisconsin, Froedtert Hospital, Versiti Blood Center of Wisconsin, and the Zablocki VA Medical Center. The CTSI works collaboratively across all of our member institutions in advancing biomedical research and finding new drugs, treatments, therapeutics, and interventions that are better, faster, and more economical than ever. Our mission is advancing health through research and discovery. Spring is in the air. And, with it, a breath of relief following a long winter. But for over 26 million Americans, including more than 6 million children, our April showers and May flowers present challenges to their chronic breathing condition known as asthma. Perhaps you know someone who suffers from it, or maybe you have it yourself. But what exactly is asthma? What causes it? And how is it treated? Dr. Joshua Steinberg is part of a team of physicians treating pediatric and adult asthma patients at Children's Hospital of Wisconsin. We sat down recently with him to learn all about asthma. Dr. Steinberg begins with a simple explanation of what asthma is.
Asthma is a chronic lung condition that causes trouble getting the air out of the lungs.
And because there's often misconceptions, he tells us what asthma is not.
Some of the common misconceptions is you have to be wheezing if you have asthma, or that if it's mild, it's not asthma, and it's hard sometimes to separate out what's asthma and what's other reasons for the difficulty with breathing.
So to help us better understand what someone suffering from asthma is physically going through,
I usually sum it up in 3 separate problems that are happening. One of them is there's a muscle around the airway tubes that tightens up very quickly. The other 2 problems have to do with the inside of the airway tubes, where they become either swollen and or they have more mucus production. And all of those things together result in the airway tube becoming much more narrow. Children with asthma, either suddenly or chronically, can have airway tubes that are much more narrow, and they are literally struggling to get air moving.
Dr. Steinberg shares an example of what it's like trying to breathe during an asthma attack.
I use the example of a coffee stirrer. As you know, a coffee stirrer is very narrow, and it's extremely difficult to breathe through it. The resistance and the effort to move air through that tube goes up literally exponentially. So going from a coffee stirrer to a wider straw makes a huge difference in how easy it is to breathe.
What's known about the causes of asthma, especially in children?
We know that there's a strong genetic influence. Children of parents who have a history of asthma have a much higher risk of having asthma themselves. That being said, genetics don't clearly determine whether you're going to have it yourself. Unfortunately, the research to look into the genetics of what causes asthma haven't really found a single gene.
Which means, in addition to genetics, there's environmental causes of asthma.
Our environment is a major factor for the development of asthma, especially in kids. Exposure to irritants in the air, especially cigarette smoke, being near a highway, ozone are all very strong irritants in the airway.
And in addition to known causes of asthma, there's a long list of things that can trigger asthma attacks.
In terms of the triggers for causing the illness, that can be a little bit of a different list. In children, that's usually viruses, especially the common cold viruses. September, when kids go back to school, incidence for asthma across the country and here in Milwaukee, admission rates to the emergency room and to the hospital double every year. Other factors include exposure to pollution or irritants in the air, exposure to known allergens, exposure to chemicals, cold weather, heat waves, because ozone levels go up in the air, and dusty areas or areas with high mold counts.
When someone suffers from asthma, what are symptoms? Dr. Steinberg shares the most common ones.
The top 4, a chronic, usually dry, non-productive cough. Wheezing, which is a whistling sound that usually happens at the end of a breath. Chest tightness, so I've heard it described where you feel like there's an elephant on your chest or there's a belt tightening around it. And shortness of breath is the 4th symptom, a sensation where you just cannot get enough air sufficiently in or out.
But he adds there are people with asthma who don't even recognize their symptoms.
Many patients have significant asthma that they may not notice because they've been used to it. This is their status quo. And some people truly just don't feel these symptoms particularly well because their body just doesn't happen to recognize those particular complaints. That's actually fairly common, unfortunately.
How is asthma typically diagnosed? There are effective tests, but with small children, it can be challenging.
Many times it's what we call a clinical diagnosis. We don't have hard proof. However, the symptoms are typical and they respond to the usual medicines. For kids under age 5, we almost always have to make a diagnosis this way because they are too young to perform any breathing tests. For older children and for adults, we can do a test which definitively determines if somebody does or doesn't have asthma. Essentially, with that test, a child or an adult will breathe as hard as they can in and out of a tube, and a computer will measure how fast the air is moving in and out. So if we see that it's taking longer to get the air out of the lungs, or if the air is coming out slower, and we can reverse that trend with an asthma medicine, that's how we can confirm asthma objectively.
Objectively, yes. But it's not always confirmed immediately.
It's hard to catch it red-handed, and a lot of people with asthma will have a normal breathing test when they come in on that day. So we usually need to follow this over time and to see the response to medicines to be sure of a diagnosis.
We know that asthma is a chronic condition, but does it necessarily affect someone every day?
Everyone's pattern is completely different. Some patients have something called intermittent asthma, where they have symptoms typically just with exercising, occasionally with a cold. They don't end up in the hospital most often, and typically they do very well with the simple rescue medicine. There's other patients with what we call persistent asthma, and those patients can either have high risk, where they're in the hospital often, or they may just have symptoms on a frequent basis.
Next, Dr. Steinberg tells us about current medications for treating asthma.
Most of our medications for asthma are used in an inhaler format. The most universal medicine for asthma is albuterol. That hormone causes the muscles in the small airways to loosen up. It's like someone unties your shoelace. It works very quickly, so all patients with asthma, we recommend having a portable device that they can keep in their pocket, ready to use whenever they may have symptoms.
And he says the landscape is ever-changing, with development of new asthma medications.
We have a lot of new medicines that have just come out in the last few years, which we call biologics. These are medicines that really target the cause of the inflammation and have really revolutionized our treatment for severe asthmatics. Those medicines are very expensive. We really reserve them for our patients who are really struggling despite taking the medicines such as the inhaled steroids and such as the rescue albuterol.
As you heard, Dr. Steinberg refers to albuterol as a rescue medication.
Albuterol works very quickly, but it really doesn't last very long. So we call that rescue medicine because it works so quickly. However, it really doesn't work particularly well to control long-term symptoms.
Compared to others, which he refers to as controller medications.
Our controller medicine's more of a prevention medicine, so it keeps the symptoms controlled, but they don't work quickly. Controller medicine can take upwards of 12 hours to start working, so using it when you're in trouble really isn't going to get you out of trouble.
Overall, both the rescue and controller medications are effective in treating asthma.
For most patients with asthma, we have incredibly safe and effective medicines that work and have very few side effects.
But even with today's medications, effectively treating asthma requires a good management plan. Dr. Steinberg shares a plan that he and his cohorts at Children's Hospital of Wisconsin provide to parents that categorizes asthma into 3 zones. The green zone,
where you're feeling well, when they are feeling well, we still want them to be on active treatment. They may need those controller medicines to keep their asthma doing well.
The yellow zone.
Yellow zone when they feel worse or have a cold, have a flare-up, so they can adjust their medicines as best possible.
And the red zone.
Red zone's where patients really do need to be in an emergency room and do whatever they can at home to get themselves there safely.
Does treating pediatric asthma require a different approach than treating adult asthma? You might think so, but
presently, our treatment plans are essentially the same. We're using a lot of the same medicines and the same approaches for kids and adults. But the future is probably going to see phenotyping where we can find out the type of pattern of asthma going on and then customizing for that patient their specific treatment regimen.
He's referring to precision medicine. We talk about it often. And it's the future of asthma treatment as well.
Asthma probably isn't one disease, it's probably multiple diseases. Unfortunately, with asthma, we've really not found a good biomarker to help quickly identify what type of asthma someone has and which medicines are going to help. We're hoping in the next 20 years or so that we'll be able to have individualized therapies that specifically target the type of inflammation that we're seeing and or the type of risk that we're seeing to get patients better quicker.
Dr. Steinberg and his cohorts see not only the physical toll of asthma, but also how it affects quality of life.
There's lots of ways it affects quality of life. We see kids that are frankly depressed, teased. Kids miss a tremendous amount of school due to this. It's a colossal problem.
And he's experienced the impact of asthma not only in his professional life, but in his personal life as well.
I've had a strong family history of asthma. My father, in fact, actually had to move. He was told by their doctor, get out of town, and he did. The family moved. Even back in the 80s when I was a kid, it was somewhat terrifying to see my sibling struggling to breathe and being a child, who didn't really know what to do to help, and I really couldn't.
But that was then. Today,
in the role that I have now, we can make a change, and usually it's a substantial change. In medicine, we can't always fix everything, but with asthma, it's reversible. We can't prevent it, we can't cure it right now, but we can really control it if we get it right.
Finally, Dr. Steinberg has these key points he emphasizes for the parents of children suffering from asthma.
I'd like them to know that it's very common. I really want to understand that it's treatable. And then I think the third thing is we don't have this all figured out. So we can catch asthma quickly, and then we can get kids to the right amount of medicine with the right expertise in a fairly short period of time.
In addition to his clinical work with patients, Dr. Steinberg is part of a research team studying the impact of asthma right here in our community. Let's learn more about that from Kayla Pierce.
That's right, Brian. Dr. Steinberg worked alongside Dr. Ann Dressel, Assistant Professor and Director of the Center for Global Health Equity in the College of Nursing at the University of Wisconsin-Milwaukee. Together, they co-led a study focusing on the indoor air quality at several Milwaukee daycare centers and the impact it's having on children with pediatric asthma. We spoke with Dr. Dressel recently to learn more. First, she provides perspective on the significant health burden asthma presents, both locally and nationally.
Asthma is one of the most common chronic lung conditions among children, and it's also one of the United States' most common and costly diseases. And unfortunately, it's been increasing since the 1980s among all groups, regardless of sex, ethnicity, or age.
And she puts some numbers to this in order to help us understand just how costly pediatric asthma is.
Currently, about 6.2 million children have asthma. And the annual direct healthcare cost of asthma is about $50.1 billion.
Recently, Dr. Dressel and MCW's Dr. Joshua Steinberg completed a study in which they addressed a key trigger of pediatric asthma, indoor air quality. For their study, they focused on area daycare settings.
Outdoor air quality has been studied a lot, but indoor air quality has not been studied as extensively, but it's believed to be 5 times worse than outdoor air quality. And young children can spend up to 10 hours per day in daycares. So indoor air quality can have a big impact on kids' health, and it's largely unregulated in daycares here in Wisconsin.
She says that earlier there was other work done that helped identify the need for their study.
Preliminary work for this study grew out of the Westlawn Partnership for a Healthier Environment to identify, prioritize, and address environmental health concerns in Westlawn, the state of Wisconsin's largest public housing development. Their top 5 health concerns, 4 were related to asthma and asthma triggers. And indoor air quality was one of those top 5 priorities.
Knowing that there was interest in addressing air quality concerns, an earlier pilot study was conducted to see if using more environmentally friendly cleaning supplies in daycares could positively impact air quality.
This Westlawn Partnership group did a pilot study providing some some education about how to use environmentally friendly, non-toxic cleaning products in daycares to improve indoor air quality. We got good feedback. The kids seem to be doing better.
But while anecdotal feedback seemed to indicate green cleaning supplies helped improve air quality, Dr. Dressel says they needed to prove its efficacy.
What's new about the study we're doing now is now we have a way to objectively measure the air quality, collect some baseline data about what is air quality like in our daycares here in Milwaukee. And then we deliver this green clean education to the daycares and figure out, did that education have any impact? Did they change any cleaning practices? Has it resulted in better or improved indoor air quality?
The study focused on daycare centers primarily serving underrepresented populations in hopes of addressing large disparities in pediatric asthma rates among the most vulnerable groups, including African American children.
For example, nationally, African American children have a 70% higher prevalence of asthma. African American kids are 3.8 times more likely to visit the emergency room for asthma. They're more than 7 times more likely to die from asthma-related causes, and they're 4 times more likely to be admitted to the hospital for asthma.
Latino children.
Latino children, too, are more at risk. They're almost twice as likely to be admitted to the hospital for asthma and twice as likely to die from asthma-related causes.
And children from low-income households.
Children from low-income families are more likely to have asthma, less likely to have health insurance. And also, low-income families tend to live in less healthy housing. And some of these daycares are home daycares, so they might be older homes, which might be more prone to have mold and things like that.
In daycares, their study focused on measuring 2 groups of airborne allergens. The first group,
ultrafine particles, really tiny particles that can get deep into your lungs and can cause the most trouble. Pollution like exhaust from cars and vehicles, but things too like pollen or mold or that sort of thing.
And the second group,
indoor organic pollution that comes from the thousands of chemicals we use and are exposed to each day, including household cleaning products, disinfecting products, pesticides, and that sort of thing.
How did the study work with caregivers at daycares to help reduce these airborne allergens that can trigger attacks in kids with asthma? What was the process?
We reached out to area daycares to invite them to participate. We contacted 36 daycares. Half of those were small daycares, which would be 8 kids or less, and then half were large daycare centers. And then the ones who agreed, first we went and installed a FooBot.
Wait, did she just say FooBot? What's a FooBot? Is that an acronym?
It's actually not an acronym. FOOBOT. It's a consumer-grade technology that you can plug into a socket, and it continuously measures air quality. So now we've got a way to collect some baseline data about what is air quality like in our daycares here in Milwaukee. They're relatively cheap, but they'll collect the data, and then you can see the data right there in your computer or something like that.
Once FooBots were installed to collect baseline data on the air quality of these daycares,
then we delivered what's called Green Cleaning for Asthma education to the daycare staff. And this is something that Fight Asthma Milwaukee Allies has developed and had a lot of success with, focused on green cleaning practices.
She gives some examples.
What can you use to replace things that might unclog your drain? Things like Drano are highly toxic. How to replace these chemically filled cleaning products with environmentally friendly, non-toxic products, mostly vinegar and baking soda.
And where something stronger is needed for cleaning, providing better instruction.
The issue with daycares is the state does require that they clean with bleach, but what we found is most people use way too much than what's needed. So again, it was educating how to properly mix up a proportion of bleach with water for cleaning.
As far as the data that was collected from the FooBots placed at daycares in the study,
we're just starting to look at the results, but some of the anecdotal evidence we have from that previous study, all of them had made changes to how they clean their daycares. So there's enthusiasm on the part of the daycare staff we've worked with, but as far as our actual data, that is just starting to come in from the FooBots.
So while it's too early to know its efficacy yet, Dr. Dressel is hopeful that their study shows impact now and can lead to future studies.
Ideally, our findings from this will lead to a larger study so we can do more extensive analysis of the impact of switching to green cleaning products. We're hoping it can have an impact locally and nationally with the state regulations governing daycares to help improve indoor air quality.
Leading to longer-term, bigger picture impact.
We're hoping it'll lead to broader community implementation. So it'd be good to raise awareness. It'd be ideal to change the regulations, especially in daycares. They're starting to do some of that in schools, but daycares is a new population to be reached with this kind of work.
She adds that a key aspect of this study is collaboration.
We've been working with Medical College of Wisconsin, Dr. Joshua Steinberg. He's a very smart guy. Fight Asthma Milwaukee Allies, they've been a key part of this. It could not have happened without them. They're the ones who have this green cleaning curriculum. The University of Wisconsin-Milwaukee College of Nursing, our nursing students have to do a population health practicum. So this gives our students a chance to impact a much broader group of people at one time.
Dr. Dressel says this air quality study is poised to provide lots of learning opportunities, including for daycare workers.
We're hoping they'll clean with non-toxic cleaners, and they're in a wonderful position to share that information with all the parents they come into contact with other daycare staff they come into contact with.
For the study's researchers and collaborators,
it's very eye-opening for them to be working in the community. It really helps them understand where people are living, where people are working, where kids are spending their time.
And especially parents of children with asthma.
Prevention is really important when it comes to asthma. So it's much better for the child if we can prevent a child from having an asthma attack or their asthma from getting worse. And a piece of that is making sure you have good indoor air quality. A study such as this can help to inform that.
Finally, if you want to learn more about pediatric asthma, there are plenty of resources available.
I would encourage people to go to the Fight Asthma Milwaukee Allies website. Also, the U.S. EPA, Environmental Protection Agency, the Centers for Disease Control, and the Wisconsin Asthma Coalition, all of their websites have got a wealth of information.
Brian, maybe we can provide some links on the CTSI website along with the podcast of this show.
We can, and we will. Thanks, Kayla. Continuing our focus on asthma, we discover an experimental drug treatment that could make the inhaler go the way of the rotary dial phone. Dr. Douglas Stafford is director of the Milwaukee Institute for Drug Discovery at the University of Wisconsin-Milwaukee. Dr. Alexander Legge Arnold is an associate professor of chemistry and biochemistry at UWM. We spoke with both to learn more about the drug they're developing. Dr. Stafford begins by explaining what the Milwaukee Institute for Drug Discovery is.
The MIDD was established to put some structure around some faculty members developing novel drugs, principally based on medicinal chemistry, and to move projects from the basic research to later stages of development. Many different roles that we engage in, but in general it's to support that collective interest in drug discovery for numerous unmet medical needs.
One such unmet need is an oral treatment for asthma sufferers that doesn't involve the use of an inhaler, which Dr. Arnold says present challenges, especially for kids.
One of the biggest drawbacks is compliance. If you give the child the inhaler, you're not really sure if it's used correctly at that point. Children, they are all over the place and they don't really adhere to a strict organization when you have to take your medication.
So taking the inhaler away from a child gives control back to the parents.
Parental control is very important here, and with an oral form of a medication to treat asthma exacerbation, we can actually have control over giving that child a medication where the parent can actually see that the medication is being taken continuous over weeks or months.
Their experimental drug also eliminates the need for steroid drugs used in inhalers.
So steroids are a very important part of medication, but they can also do a lot of harm if they are being used over a long period of time. There have been studies where child development is impeded by the use of steroids for a longer period of time. This really motivated us to develop an anti-inflammatory which is not based on a steroid. We would like to do it in a way so that this medication can be taken chronically.
Their revolutionary drug compound was developed by another of their cohorts, Dr. James Cook. Was it originally designed to treat asthma?
It's a good question. So when we are making molecules in the laboratory, most of the time we are not making one particular molecule, but we are making many of them. This was the same case with this particular compound, which was not developed for a particular purpose, but it was developed within a series of compounds.
And it was years after its development that they discovered it might be effective in treating asthma.
This particular compound was very important for us because we could use this particular medication orally, but we are not getting any exposure in the brain. And this is very important if we want to treat asthma, because we would like to make sure that our compound is only distributed in the organs we are actually targeting.
Today, their oral asthma compound is in preclinical trials.
We are currently trying to get all the necessary toxicity studies done with this compound, so this is the first step for an FDA approval, which then allows you to actually test your compounds in humans. And so this compound is non-toxic. We are very happy with that. Next, in order to use higher quality of our compound, we are using a company who is making that compound for us so that we can actually later give it to humans.
Are we close to potentially seeing this experimental drug used in human testing?
Yeah, I think we are getting relatively close. We have a startup company here at UWM, which is called Bentherix Incorporated. So we are trying from an academic approach as well as an industrial approach in order to bring this compound into clinical trials as soon as possible.
Dr. Stafford elaborates.
I think the question is, when would be the first human exposure? And we can see that happening in about a year. So that's a big milestone for any drug discovery, to take that molecule, which was not that long ago just a concept on a whiteboard, that leads one to what we call a clinical lead that's suitable for human testing. Once the molecule enters initial human testing, it's probably a matter of years. It's still out there ways, so it will require substantial testing, but that's the pathway that's required, and we're about to launch into that.
So if all goes well, and this oral treatment does one day eliminate the need for inhalers, what would that mean for young asthma sufferers and their parents? Dr. Arnold.
I think it would be a relief, especially for the parent, anxious about that child getting an asthma attack in a situation where they are not present. Now, with an oral application, we can reduce that risk, so we could have the parents be less anxious. I think for the child, it's a social aspect. Because if the child is taking an inhaler and is the only one, there can be some social pressure that the child is not taking the medication because of that environment. And so this would also fall away with an oral medication.
Dr. Stafford adds that it could also reduce the misuse of asthma medication.
Many people who use inhalers use them incorrectly. There's a substantial amount of training that's involved in teaching the patient how to use that, so that you're actually inhaling the drug rather than swallowing the drug. The drug needs to go into your lung, not your stomach, in order for it to work. And we think that the oral form, the pill form, is going to be a much better way to do that.
This speaks to the value and strength of UWM's Milwaukee Institute for Drug Discovery.
When you look at a drug discovery such as this, it's very much interdisciplinary. It's not just a chemist, it's not just a biologist, it's not just a physician. It's really an interdisciplinary team of a lot of different skills coming together. And much of the work that's done is by graduate students who are working on their PhDs in chemistry. And so they really get a terrific experience seeing how these projects come together. And I think that's what the Institute tries to promote, is this interdisciplinary working.
And it's not only graduate students helping out.
We are also trying to get undergrad students the opportunity to work on a project like our asthma project. What I see in my laboratories, undergrad students are coming to me and saying, Dr. Arnold, I want to work on your asthma project because I have asthma. And this is something which I really embrace. We are not only giving out degrees, but interested students can come to us and can take this information to the next level.
But they recognize they can't bring this asthma treatment to market on their own.
UWM really focuses on the basic science. When a project like this advances to clinical testing, we have to team up. And so having the linkages through the CTSI and other collaborative networks is really important for this to happen, so that we can collaborate on all of the steps that are necessary to translate the basic science now into a drug that's being tested in human beings. We all see a win as a win for everyone here in the community, and I think that's really gratifying in working within this consortium in Milwaukee.
Finally, what's it like developing a new drug that could positively impact the health and quality of life for potentially millions of people?
I can say from personal experience, I've had the privilege to do this in the past, where an idea of yours actually gets to the point of a human being volunteering through informed consent to use your drug in their body. It's not some theory in a textbook. This is real people in our neighborhoods, and these people are going to be participating, hopefully, in the development of this drug.
It's always great to hear about new discoveries. But now we're out of time for this edition of CTSI Discovery Radio. Our sincere thanks to today's guests, Dr. Joshua Steinberg, Dr. Ann Dressel, Dr. Douglas Stafford, and Dr. Alexander Legge Arnold. I hope you've discovered something by listening to today's show, and I'm doubly hopeful that you'll join us again next time. CTSI Discovery Radio airs the third Friday of every month, so make an appointment on your calendar and join us for each episode. On behalf of the Clinical and Translational Science Institute of Southeast Wisconsin and all of our affiliate partners and members, along with Caleb Pierce, I'm Brian Belmer, wishing you happier, healthier days ahead. For more information about research or to listen to this program online and on demand, please visit the Clinical and Translational Science Institute of Southeast Wisconsin website at ctsi.mcw.edu. CTSI Discovery Radio is written, produced, and hosted by Brian Belmer in collaboration with WMSE Radio. The CTSI and this program are under the direction of Dr. Reza Shakir.